This video will show how to create input-output tables in Desmos to explore the left tail and right tail behavior of this function. So I've already defined the function f of x in Desmos. I want to explore first the left tail behavior of this function. So I'm going to go ahead and add an item by adding a table. I'm going to input x and output f of x into this. If I want to explore the left tail behavior, I want to plug in x values that diverge to the left, diverge down towards negative infinity. So I might plug in values like negative 100, negative 1,000, negative 10,000, lower, 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 getting closer and closer to negative infinity. And then I look at the y values and I see that they do seem to have a limiting value of approximately 2.718. And if you continue this and go even further, hopefully you will start to see that it is approaching e. This function on the left tail is flattening out to a height of y equals e. I'm now going to add another table where I explore the right tail function behavior. So I do a very similar process. This time my x's are going to diverge off to the right. They're going to diverge to infinity. So I plug in values like x is 100, x is 1,000. They're going higher, higher, higher on the right side. And again, we see that the y values are approaching a limiting value of about 2.71828, which we see then the y values are approaching e. It turns out, if I turn on this graph, we see that the function's graph flattens out to approach a y value of e. And I could even throw in that horizontal asymptote. So I'm going to define the horizontal asymptote of y equals e. I'll make it a blue dashed line, and we see that the graph of f of x on the left tail and on the right tail flattens out towards a horizontal asymptote of y equals e.